Welcome to The Explainer. Today, we're jumping right into something absolutely incredible, the awe-inspiring return of humanity to deep space aboard Artemis II. Now, make no mistake, this isn't just another routine test flight. This is a historic threshold we're crossing. We are literally transitioning from our low Earth orbit past straight into our future as a true spacefaring species. Just take a second and imagine the stark, absolute silence of the lunar surface. It's a silence that humanity is finally ready to shatter. We're officially trading the crackly, archival audio of the Apollo days for the sudden, raw, earth-shaking power of a modern rocket core stage, thrusting us right back out into the void.
So here is our flight plan for today's Explainer. First, 54 years in the making. Then, the SLS and Orion. Next, we'll meet the historic crew. After that, slingshot around the moon. Then, trial by fire re-entry. And finally, stepping stones to Mars.
Starting with Section 1, 54 years in the making. Can you believe it's been a 54-year gap since humanity last ventured beyond low Earth orbit? I mean, after Apollo 17 touchdown in 1972, we basically parked our deep space ambitions and shifted all our focus closer to home, heavily utilizing the space shuttle and building the International Space Station. Rebuilding the actual capability to safely fly humans back to the moon? Well, that took 5 decades of massive engineering hurdles and constantly shifting political landscapes.
But what's really fascinating here is the cultural shift. We aren't racing a Cold War adversary just to plant a flag and go home anymore. Not at all. Instead, we are building a peaceful international lunar economy. Think about it, the Artemis Accords now bind over 60 different nations to transparent, cooperative exploration. And we're heavily integrating commercial space partners to make sure this time our presence is actually sustainable.
Moving right along to Section 2, the SLS and Orion.
Okay, so let's talk hardware. We have to talk about the Space Launch System, or SLS. This thing is a towering 322-foot technological marvel specifically designed to push incredibly heavy payloads completely out of Earth's gravity well. Standing even taller than the Statue of Liberty, the SLS was built by a massive coalition. We're talking over 1,100 contracting companies spread across all 50 U.S. states. It beautifully integrates proven shuttle-era technology with next-generation manufacturing.
But here's the number that really matters. 8.8 million. At liftoff, the 4 main engines and the twin solid rocket boosters generate a staggering 8.8 million pounds of thrust. That makes it the most powerful operational rocket ever successfully utilized for a crewed launch. It literally shakes the Florida coast to its absolute core as it pushes for orbit.
And sitting up at the very top of that controlled explosion is what the Artemis II crew has named Integrity. That's the Orion spacecraft. It is the pressurized vessel that keeps the crew alive against all odds, serving as their home, their command center, and if necessary, their lifeboat. Orion is a massive international achievement in its own right. It actually gives the astronauts about 60% more habitable room than the old Apollo capsules did. But the coolest part? It relies heavily on the European service module, which was built by Airbus. This module handles the really vital stuff: power, propulsion, thermal control, life support gases. So we've literally woven international partnership right into the hardware itself.
Let's move to Section 3, meet the historic crew.
Because hardware is nothing without the humans flying it, right? And this crew is a brilliant reflection of humanity, showing unprecedented diversity. We've got Commander Reed Wiseman at the helm, pilot Victor Glover, who is making history as the first person of color to travel beyond low Earth orbit, mission specialist Christina Koch, who already holds the record for the longest single space flight by a woman, and Jeremy Hansen, who represents that powerful partnership with the Canadian Space Agency, becoming the very first non-American to venture this far into deep space.
I absolutely love this quote from Christina Koch. She shows that the crew views Artemis II not just as a one-off adventure, but as a critical relay race. They've been going through some grueling stuff: high-G centrifuge training, intense water survival drills, endless simulator sessions, all to test life support, fix anomalies on the fly, and lay down the exact procedures that future lunar landing crews are going to need to survive. They are literally passing the baton.
All right, Section 4, slingshot around the moon. So how do they actually get there? The flight profile is frankly brilliant. Instead of just shooting straight for the moon right off the pad, they first enter a 24-hour high Earth orbit. Why? To thoroughly stress test Orion's life support systems before committing to the full trip.
because once you leave the protection of Earth's magnetic field, you're exposed to harsh deep space radiation. Once they are 100% confident the shielding and systems are good to go, they execute the trans-lunar injection burn. From there, they ride a free return trajectory. This means they use lunar gravity to naturally slingshot themselves right back to Earth, completely avoiding a massive risky engine burn to get home. And by using this specific slingshot path, Artemis II reaches a mind-blowing 252,756 miles away from Earth. That officially shatters the all-time human distance record set by Apollo 13. As they pass over the lunar far side, they are plunged into a tense total communication blackout with Earth. But when they emerge on the other side, they get to witness an Earthrise from the dark void, a profoundly emotional experience that very few humans have ever had. Which brings us to Section 5, Trial by Fire Re-Entry. Because getting back is where the physics of deep space become absolutely terrifying. Smashing back into Earth's atmosphere, the outside of the Orion capsule experiences temperatures hitting nearly 5,000 degrees Fahrenheit. That's about 2,760 degrees Celsius. Just to put that into perspective for you, that is roughly half the temperature of the surface of our sun. And they hit the atmosphere at a staggering Mach 32. That's 25,000 miles per hour. At that speed, the capsule's survival relies entirely on its heat shield. The shield is made of 186 meticulously machined Avcoat blocks that are designed to ablate, meaning they intentionally burn and melt away in a highly controlled manner to carry all that extreme heat away from the crew. The shield bleeds off all that velocity until the parachutes finally deploy, leading to a gentle splashdown and a U.S. Navy recovery in the Pacific Ocean. You can almost hear the collective sigh of relief from the entire planet.
Finally, Section 6, Stepping Stones to Mars.
Artemis II isn't the finish line, it's the starting gun. The data we gather here directly feeds into Artemis 3 and 4. NASA is working with commercial landers from SpaceX and Blue Origin to actually ferry astronauts from the Orion capsule down to the lunar surface. And by the early 2030s, the blueprint includes a Lunar Gateway space station and a sustainable permanent base down at the Moon's South Pole.
Even our spacesuits are getting a massive upgrade to meet these goals. The Apollo suits were incredible, but they were basically first-generation survival tools. Astronauts constantly fought against the stiff fabric and that highly abrasive lunar dust. Today, commercial partners are building second-generation dust-tolerant suits that give astronauts the high mobility they need for 8-hour spacewalks. We are finally building the tools to truly live and work on another world.
As we wrap up this explainer, I want to leave you with this thought from NASA Associate Administrator Amit Katria. It perfectly captures the heart of this entire endeavor. Why deal with the deadly radiation, the extreme temperatures, and the immense cost? Because of the sheer awe of human exploration. Having a first-hand witness to look back at the fragility of our planet from the dark void, that is something that inspires us collectively as a species.
Artemis II proves we still have what it takes to return to deep space, to build strong global alliances, and to protect our crews in the harshest environments imaginable. We are going to the moon to stay and to learn exactly what it takes to survive out there. Which leaves us all with one massive, lingering question the next time you look up at the night sky. When will we finally take our next giant leap to Mars? Thanks so much for joining me on this explainer. Keep looking up, and I'll catch you in the next one.